Hello, everybody. Welcome back to Math 1342. We're going to start Chapter 6 now. Homework assignment 6.1. This one deals with normal distributions. All right, number one. A normal distribution is informally described as a probability distribution that is bell-shaped. Draw a rough sketch of a curve that have a bell curve having the bell shape. That is a characteristic of normal distribution. That's not bell-shaped. That's just a parabola going down, parabola going up. This is bell-shaped, but it can't be down, so it has to be D. And in the middle here, of a bell-shaped curve, that is your mean. It goes 3 standard deviations to the right and 3 to the left. All right, what requirements are necessary for normal distribution to be a standard normal probability distribution? Okay, so that's your mean. It's in the middle, so that has to be 0. And then each one, there's 1 plus 1 is 2, 2 plus 1 is 3. So the standard deviations, the mu has to be 0, and standard deviations each have to be 1. Standard deviation it has to start off at 0. And the standard deviation can't be 0 because then it wouldn't go anywhere. So the answer is C. All right, now this one's saying for a waiting time between the subway departure schedule and the arrival of a passenger are uniformly distributed between 0 and 7. So between 0 and 7 minutes. Find the probability that a randomly selected passenger has a waiting time greater than 2.25 minutes. Find the probability of, all right, there's a difference between this one now. This is a uniformly distributed shape. What that corresponds to, since we're given this information, we know it's between 0 and 7. It's rectangular in form. So we have to do, this is the width, and this is the height. We have to figure out, first off, what is the height? The area of this rectangle has to equal to 1. So the area formula is length or width times height. If the area is 1 and the width is 7, what's the height? So divide both sides by 7. So the height is 1 over 7. And what we do that is be a 0.1429 something or 28 something. We just want 2 decimal places. So 0.14. All right, so now we have the formula of this thing. Ours says specifically the waiting time is greater than 2.5 or 2.25. So let me just scratch paper. I'll use the back. No, I'll probably do it here. So I'm looking for the probability greater than 2.25. So if that's between 7, this is 3.5. 2.25 is about here. We want to know what that area is. So if we want to know this area, we know the height is 0.14. We have to find this length here. So the difference between these two is 7 minus 2.25. That's the width times the height is 0.14. Put that in the calculator. So this is 4.75 times 0.14, which gives us 0.665. That's what we're looking at. So there's a 0.665% chance that they're going to wait greater than 2.5 minutes. Right. Number 4. Find the indicated z-score. The graph depicts a standard normal distribution, mean 0, and standard deviation 1. So we're looking for the z value given this area here. So in order to do that, we have to find our charts. Let me look for the chart. All right, so here we have the z chart. And according to our question, let's go back to that one. We want to know the area to the left of that. So here's the mean. So this is the z-score that we're looking for. Remember, since that's 0, anything to the left will be negative, anything to the right is positive. So we have to look at what's the z-score that has this area, 0.2206. So what we do here, since we're on the negative side, on the left side, we have to use the negative numbers. These are positive numbers. These are, if you look at the graphs, these are for the areas to the left of the mean. These are for the areas to the right of the mean, and they go to the left. Okay, so we're looking for 0.2206. So we keep on looking at all these numbers till we find 0.2206. It is right there. Okay, so we see that it's on the negative 0.7. And let's see where it goes up. That's the first digit. 7 is a decimal 7. The second digit goes all the way up here. And the second digit is 7. So it's negative 0.77. So this answer here is negative 0.77. All of my pens are dying. So it's negative 0.77. All right. Now we want to look for the right-hand side. We want to look for 0.7088. And the z-score, the z number is to the left of the 0. So we know it's going to be negative. We have to find the number. But remember, our charts only go to the left. So let's find this area. And that's going to tell us the z number. How do we find this area? This area here. So we know the whole area has to equal 1.00. If we take away the 0.7088, so that's going to be 0, 9, 9, 9, 10. So it's going to be 2, 1, Okay, so yeah, so let's look at that. We're looking for the area of 2912. (2912) is here. So it's negative 0.5 and go all the way to the top, 5. So our answer is negative 0.55. So it's negative 0.55. Remember, our chart only finds this area. So we have to find what area is that by subtracting it. Okay, number 6. Assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with a mean of 0 and standard deviation of 1. Draw a graph, find the probability of a bone density test score that is greater than negative 1.68. So negative 1.68. It's greater than. That's less than, so that can't be right. This is less than, it's a positive number, so that can't be right. So here's negative 1.68, and it's greater than, so it has to be C. All right, so now let's look at what the value is of that one. It's going to be pretty big because remember, this area here, this half is 0.5. That's half of it. Now we have to find from our chart, or to find this amount, subtract it from 0.5, or take this value, subtract it from 1. So let's go look for negative 1.68. So now, since that gave us a Z value, we have to go here on the left-hand side and look for negative 1.6 and go all the way to 8. 8 is always to this far side here. So that's the negative 6 on that white line. So this area here is 0.0465. So take 1. So we take 1.0000 minus 0.0465. Ten minus 5 is 5. 9 minus 6 is 3. 9 minus 4 is 5. So the probability is 0.5 or 95.35%. However they want it. So they want it in decimals places, 4 decimal places. So it's going to be this one. So it's 0.9535. Number 7. Find the indicated area under the curve for standard normal distribution, then convert it to a percentage and fill in the blanks. Fill in the blank. About how many percent is the area between -2? So here's 0. So -2 standard deviations to 2 standard deviations. How much is this area? Okay. Since these two areas are the same amount, because it's symmetric. Once we find this area, this percentage, we multiply it by 2 and subtract it from 1. Because if we multiply by 2, we get both of those. So we're looking, what is to the left of negative 2 point? Negative 2.00. Okay, so our z value is 2.00, which is this number right there. It's 0.0228. So that area is 0.0228, which means this area is 0.0228. So 0.0228, if we double it, 16,540. So that's both of those areas. The whole picture is 1.000 minus 0.046456. So it's 4, 4, 9544 times 100 is 95.44%. No, 95, not 9. 95.4, 44 or 45. Excuse me. Sorry about that. So our answer is going to be either 95.44% or 95.45% if they wanted to round it or just truncate it. All right, number 8. For bone density score that normally distributed with a mean of 0, standard deviation of 1, find the percentage of scores that are A, significantly high, in other words, at least. So the first one's looking for, here's the mean. So we want to greater than that. At low, at least 2 standard deviations below the mean, and not significant, which means they're between -2 and 2. So basically, once we find both of those, subtract it from 1, we have the remainder. Remember, it's symmetric. So once we find this one and this one, they're both going to be the same. So we're looking at our chart. So we want to go 2.00, which is that number right there. So the second digit is 0. 2.00 is that one. 0.0228. So it's 0.0228. So times that by 100, move decimal 2, so it's 2.28%. 2.28%, 2 decimal places. And then what's in the middle? So if we do 2.28% times 2, that's the 4% that puts together both of those ends. 100% minus 4.56% is 95.44. 95.44%. Again, so, or if we had another chart that was more accurate, typically some charts will tell you that instead of 0.0228, it'll even be more accurate, you're 0.2285. So if you use this chart, it's going to be 95.45. So it all depends on the accuracy of the chart that we have. Right. That's it for this section. Good luck, everyone.